All right. So if we are going to expand using the properties of logarithms, that means take the one logarithm and break it down, break its operations down, and try to create more logarithms, right? Write a long expression with as many logarithms as possible, basically, is expansion. So we have the log of a quotient, right? The log of a quotient can be broken down, and I don't want to get too far into semantics here, but the log of a quotient is different than the quotient of two logarithms. So in other words, if I ever have this, okay, that is the quotient of two logs. There's only one thing I can do with that, and it's not what you're about to see. This is different from having the logarithm of a quotient, not the quotient of logarithms. It's semantics, but the rules are very strict when it comes to this. So the logarithm of a quotient, I can separate the quotient into subtraction. When you divide exponents, you can subtract them. When you divide within a log, you can subtract two logs. So this is log base x of y squared cubed root of z minus log base x of a to the fourth. So the log of a quotient becomes the difference of two logs. Now, something I probably should have mentioned from the beginning, radicals and logarithms, they speak in a different language. Because logarithms are the inverse operation of exponents, you should typically write your radicals in exponential form. So in other words, how can I write this term using an exponent? Z to the 1/3, right? Radicals are written as fractional exponents. So this is z to the 1/3. It's just good practice, okay? Radicals and logarithms, logarithms and exponents, they're speaking the same language. It's, they are spirit animals. They are similar operations. So now I'm not done because I have a logarithm of a product. I can separate the product into a sum of two logs. So I have log base x of y squared plus log base x of z to the third minus log base x of a to the fourth. And because I'm trying to make this as expanded as possible, as complicated as possible, anytime you have an exponent inside of a logarithm, you can move that exponent. So whatever the base is stays, the exponent comes in front, right? It's like my daughter. It's like if she notices a box of tissues that hasn't been like completely emptied, she has to empty it. It's like a reflex. So it's like, oh wait, there's a box of tissues that has actually, that the tissues are actually in it, like in the manner they're supposed to be. I better go make a mess of that. Like it just has to happen, right? Similar here. It's like having a log with a power inside. It's like, no, that's not supposed to happen. Just move it down in front. Like it should be a reflex. It should be natural. So this is the expanded form of that. Using the same concepts, right? The addition of two logs is a product, or a log of a product is the addition of two logs. It's the same property used in reverse.